Hey there, Brittany. Welcome to the Making Math Moments That Matter podcast. We are excited to talk with you and to dig into your virtual summit session that's coming up. But before we get to all that, give our listeners a kind of a snippet. Where are you coming from? What are you doing in math world these days?
Yeah, well, first off, thank you so much for having me. It is such an honor to be here since I listen to your podcast. So it's a treat to get to talk to y'all. But my name is Brittany Hege, and I am the creator behind Mix and Math. I was a teacher. I did some work as an interventionist and a coach, and then I just fell in love with creating light bulb moments for teachers. And I do it online and in person at conferences or doing in-person professional development. But yeah, I'm here in North Carolina, sunny North Carolina, and it's a treat to get to talk math with thousands of teachers across the world.
That is awesome. Well, thank you for taking the time. The last time we had seen you in the flesh, John, I'm trying to picture, was that NCTM last year?
Yeah, it was a year ago. It was a year ago.
Yeah, it was very, very cool to see you in the concrete form, because we usually see you in the digital form online. So thank you for taking some time to join us. And we're really excited to not only chat with you here today, but also to give you an opportunity to kind of give a glimpse into that summit session that's coming up. So we're super excited for that. But before we do, like we do on every episode with all of our guests, we like to put it to you and get you to think back to that math moment that sort of stuck with you throughout the years. When we say math, mathematics, math class, what memory pops into your mind? And do us a favor to let us know how it's affected you.
Yeah. So funny enough, I knew y'all would ask this, and I have a terrible memory. Like, I truly do not have many memories of learning math, either positive or negative. And so I spent some time thinking through this, and I was thinking back to, so in elementary, I went to an international school in Indiana. And so I was taught by teachers. They were all from all over the place: Quebec, Zimbabwe, France, Belgium. And the way that I was taught math was so different than when I went to like the public schools in Indiana. And I just remember having to like relearn all of these algorithms, and I didn't really understand why. And I guess I was a good enough student to do it. I relearned the algorithms. I don't think I ever felt like I never understood math until I started teaching math. And this actually, I think, is probably the moment that has shaped my career. My first year teaching fifth grade math, I remember standing at the front of the classroom, and we came across a math problem. It was like, or a multiplication fact. It was like 12 times 7. And I remember standing there. I was like, all right, what's 12 times 7? And I remember looking to the student who I knew would likely know it, as I like secretly pulled out my phone and was calculating it. And I was like, oh, like that was like the first moment I realized, like, I don't understand math. And so I spent that entire first year really learning the math that I was teaching. And it is when I fell in love with math, and it is why I do what I do today.
Amazing. Amazing. And I'm super curious about that school and like what you were doing before you had to like reshuffle and kind of like adapt to the way things were being done in the public schools. But like I want to hear that, but I also I guess identify with your memory of standing in front and not really understanding math. And I'm a high school math teacher, and I felt like that a lot of the times too, even though it's like I felt like I knew math, but it was like when I really didn't really know the math, I knew the one way, and that was the algorithm way. And if you challenged me on that, I probably didn't have a great thing. I just knew that I really liked the algorithm stuff, and that's probably why I went into being a math teacher. But fill me in, give me a little snapshot of what was happening at that school before you went into the public system.
Yeah, so it was so all of our teachers were from those countries. So I was in a French immersion program in Indiana. And it was I don't remember learning math, but I know that when I came out of that school, like the algorithms looked different. Like the way you set up long division was different than the way that we do long division in the US. And the way even like regrouping for subtraction, they do that differently. So rather than like crossing out and then, regrouping the numbers, they kind of almost use, I didn't understand it at the time, they almost use like subtraction as distance. So you would like write a 1 on the bottom number and then a 1 at the top. It's really fascinating. but the algorithms are just different. And my teachers had no idea what I was doing. And they were like, no, you need to set up the division algorithm this way, and you need to do the subtraction algorithm this way. And I didn't really understand why when I was getting the right answers.
Right, right. There's so many different like approaches, right? Just like anything in life, like you could, I could cook tonight's dinner in a different series of steps and still come out with a very similar outcome. And the same is true with a lot of math, formulas that we use. There's not just one procedure, but there is an accepted procedure, right? When we say the standard algorithm for math, what we're really saying is the American algorithm for math. Like it's not like standard everywhere. It's like, it's just how we do it here. And guess what? Canadians do it too, very similar. So that's a really interesting math moment. We haven't had one quite like that, but I think it's worth everyone at home right now sort of reflecting on and thinking about this and going like, imagine a world where if we were to, like, math is supposed to be the universal language, right? Where it doesn't have borders, but yet if you get teleported into a different part of the world and they do something very differently from a procedural standpoint, that you're now talking almost a different language, that really makes you think, this is where conceptualizing the mathematics comes in such, it comes in handy for you to be able to kind of go, wait a second, if I'm not making sense of this algorithm, if I back up and I go to the conceptual pieces and I go, well, why is that working? How does that work? I can now sort of go, okay, I now trust that the way that they're doing it is actually going to come out with a very similar outcome, hopefully the same outcome as the way maybe I have been growing up doing it. So I think that's a really interesting sort of memory to share.
Well, I think what you're describing, Kyle, is what all parents are going through right now, right? In work is coming home. If you are trying to, teach in a way where you're using models, manipulative strategies, and having your kids explore that and make sure that they feel comfortable in that fluid, flexibility and fluency, and they're going home and trying to do that at home, and parents are like, this is not math. This is a different language.
This isn't multiplication.
All of a sudden we're in a different country, learning something else. Like it's completely foreign to them. And this is why everyone's saying it's new math, and it's not really new math. It's just we're representing it differently. But this is what parents are going through. Brittany, let's jump into it. Like, having talked about multiplication, let's get into it, because I know your session for the summit is going to be on multiplication of whole numbers, fractions, decimals. Tell us like what are you going to get into? Like, tell us what is like what's the pebble that's rattling around in a teacher's shoe right now, where attending your session is going to be like, pluck that thing out of there, and they're going to be like, man, I'm so glad I went.
Yeah. So I think that kind of like my inspiration for this session was the fact that a lot of times we can feel like when we start teaching a concept that we are teaching blank slates. Like, students come in and we feel like we're starting from square one, and and I'm not going to speak for every teacher, but I can speak for myself in my previous experience, maybe even some of the teachers that I work with. When we don't really understand the concept ourselves, we don't recognize that students have so much understanding that they bring to the table that allows them to be successful with the new concept that they're learning. Like, we just don't recognize. And so we aren't intentional to connect back to, oh, what have you learned in previous grades that really sets you up for success to understand this concept? And so really my session is going through that progression of multiplication from third grade all the way through sixth grade, and how what they learn in third grade really helps them multiply whole numbers, fractions, and decimals all the way through sixth grade, and how we can use different representations to show students that, look, this is the same thinking that you were doing last year. It's just maybe applied in a different way. So that's really kind of the basis of my session.
I love that. And that it really, sort of rubber stamps this idea that, if we want to teach students and meet them where they are, we have to be able to recognize what they're bringing with them to the table. And maybe they aren't bringing an algorithm memorized to the table. That's where I think that blank slate idea comes from, right? As kids forget these procedures because they're not using them. They haven't used them in their daily lives in quite some time. And then they show up in our classrooms and we think, oh, shoot, we got to start all over. However, if we're building on the same, models, representations, using strategies, and we're helping students to see that all we're doing is just shifting, the quantities that we're working with, right? Be it whole numbers, fractions, decimals, percentages, you can actually apply the same thinking without it just being a memorized procedure. So
Right.
I'm really excited about that. I would say, when you're talking to this audience, I'm wondering, who are you hoping will show up at this session? Do you think, is it only those 3 to 6 teachers, or do you feel like there might be some value in there for some teachers outside of that grade band?
Yeah, I think obviously 3rd through 6th grade teachers are going to get the most value in it because they're currently working with those concepts. But middle school teachers, I think it's important for them to recognize like what foundations their students should be coming in with. And if they do have some unfinished learning, then they, have that perspective from elementary school that they can use to kind of support their students. And I think also 2nd grade teachers to see, okay, the work that I'm doing in 2nd grade, where is it leading to? Where is it connecting? So I think kind of on the fringes of that 3rd through 6th grade mark might really get some value from it. But really that 3rd through 6th is the sweet spot.
Yeah. Yeah. And I think I'm always a big fan of kind of stretching in opposite directions to really understand, where students are coming from, where the students are going, what are the strategies and the models they're using down there or up here or side by side. We want to make sure that alignment is happening. So, I would say, beyond those grade levels, super important to also, attend and kind of learn from this session. When I think about multiplication, I hear the words all the time. I don't know about you guys, but I always hear like, what do you do when students don't know their math facts? Like when you hear that phrase as a teacher, like what do you, like if a parent is saying like kids just don't know their math facts lately, or another teacher is saying that at the staff room or the staff table, what are you telling people these days? Like, how do you address that concern? Because I know your session is going to address that because that's just the nature of what you do in your sessions. But like, how are you addressing that like lately right now when someone asks you that?
I think that math facts are important, but I also think we put maybe an overemphasis on if they don't know their math facts, they're doomed. It's right. Like we can still do work to build fluency and they can still learn grade level content. And so in thinking about just even upper elementary, where there's supposed to be, a lot of teachers will say, well, because they don't know their multiplication facts, there's absolutely no way we can talk about multiplying multi-digit numbers. And that's just not the case, right? Students still need to understand partial products. They still need to have exposure and experience with the area model. And there are a lot of things that we can do to support students as they're still working and building that fluency. There are supports that we can put in place to allow them to still work on grade level content while they are also developing fluency. So I think it's one of those things where they don't know their math facts. We can work on that, and they still have the ability to learn grade level content.
I love it. I love it. Now, I think all 3 of us here are big fans of multiplication in terms of how powerful it can be to not only, multiplication being so foundational, but also we like to call it, it has legs, right? Like we can take a lot of these strategies and stretch them all the way up, and we use it in algebra and all of the wonderful things that we can do in high school with them. What would you say is maybe a misstep that you maybe commonly see that we as educators take when we start to plan and teach multiplication?
I think maybe one of the biggest ones is, and maybe it's not the biggest one, but it's the one that I think is just the most interesting to me, is that we can take things that are models that are really strong models and really develop students' understanding and proceduralize them. So like the area model, for example, I think is a very powerful model. It's one that extends all the way through high school. I've heard high school teachers, I'm not a high school teacher, but y'all are the high school experts. I believe multiplying like polynomials. Is that what it is? Y'all use the area model for that?
Yes. 100%.
We do.
Bonus for using the word polynomial, by the way. Happens to be one of my favorite.
I was going to say, I feel very smart right now, but I do not have high school experience. But I'll hear from high school teachers, they'll be like, thank you so much for using this model in elementary. But what I've learned is that a lot of times we will proceduralize it. Like we will tell students, okay, we're going to multiply a 3-digit number by a 2-digit number. So you need to draw 2 lines this way and 1 line this way. And it's not getting at the heart of why we use an area model.
Why 2 lines? Like why? Why are we doing 2 lines?
You're just teaching them another algorithm.
Exactly. And I think even
guilty as charged in my early going, by the way, for sure.
Yes. Yeah. And I'm a huge fan of math manipulatives. And I think we can do the exact same thing and proceduralize the use of math manipulatives. So I think it's one of those things where I like to have teachers, first off, recognize that a student can decompose the numbers in any way that makes sense to them. So it may not be by place value initially, and that's totally okay. And so really just making sure that we're using these tools that are meant for good in a way that develops understanding and not turning it into another thing to just use.
So what are you sharing with teachers to say, like, instead of going like, so there's a teacher listening right now and going like, oh my gosh, I'm doing that with the area model when I thought I was doing, I was doing more deeper learning with my students on multiplication than the teacher next door, and they're just teaching the algorithm. But I'm just showing kids how to use the area model. And now I'm realizing that's not any different because I'm just showing them how to draw a picture and then fill it in. Like what is your go-to move to get a student to kind of like understand why the area model is a great model to use and not have it just be something that they have to now memorize?
Yeah. So first off, I just want to acknowledge there's no place for shame in math education. Sure. So if you are the teacher who's like, oh my gosh, I've been using it in a really procedural way, this is just an opportunity for you to learn and grow. Totally. I absolutely was that teacher. So there's no need to feel any shame about that. But as far as I think how to use it in a way that develops understanding, I think it's making those connections to the more concrete representations. So starting with whether it is grid paper is a powerful tool because you see every single unit and talking about, okay, you're modeling this multiplication fact on grid paper or even base 10 blocks. How does that connect to the work that you are doing in the area model? So yeah, that would probably be my best tip is, okay, bring it back down. I found that there's kind of a progression, just like there's a progression in the concepts that we teach. There's also a progression in the models that we use, the representations that we use.
100%.
Some are more abstract than others. So if the area model feels abstract to a student, then what's kind of the more concrete or less abstract way that we can show this concept?
I love it. I love it. And, I think too, just to kind of add on to what you're saying, I love you had me thinking, like when you talked about this idea that it's really easy for us to proceduralize, regardless of whether we're doing things symbolically, whether we're doing it, by using visuals or drawings, or whether we're doing it concretely, because once again, it's like, well, what's missing if we proceduralize it? Well, really what's missing is not asking students to do the thinking. And so, when I hear that and I go, I'm like, if we can just ask the students how they want to do it, and maybe even encourage students to, hey, let's do this multiplication using, if it's the area model, or maybe it's arrays like you had mentioned, maybe it needs to be a little more concrete than the area model for some students as they're getting started. But let's see how many different ways we can decompose these two numbers and multiply. Now, we're not talking about efficiency, obviously, because, the student that breaks down 7 into 2, 2, 2, and 1, right, is going to have a different looking picture, but ironically, the same dimensions when we put it all together, a different looking picture than a student that goes 5 and 2 to break down the 7, right? So I really like that. And I think for those who are listening, and John, like you had said, if you're trying to make these moves and you're going, shoot, maybe I'm proceduralizing this. Again, no shame. But it's like, how can I, instead of showing students, how can I ask students? Instead, if I instead of showing them how we're going to decompose it, we say, how do you want to decompose it? Right. And then maybe we ask 2 or 3 students to decompose it different ways. And we can show that this is their thinking, that they're the ones breaking this down. And they're actually showing us, hey, that I actually understand why we're doing that, because it shouldn't just be 2 lines, 2 vertical lines and 1 horizontal line because of this particular, 2-digit by 1-digit or whatever it might be. We want to make sure students are understanding it, because again, when we're not there, we want them to be able to rely on this tool to kind of guide them through the process, right? So I love that. That's fantastic. This has been an awesome overview of what people are to expect coming into this session with you, Brittany. I'm wondering, the session's over. We're going to wave a magic wand. It just happened. We're in the summit. You're about to wrap up. You're like 2 minutes before the time is up, which never happens for any of us. It's always like 4 minutes after. That's okay. No shame in that either. But you're ready to wrap up. And you think to yourself, I feel, or I hope that these educators took away this big idea. If there's one big thing that they could take away from your session, what are you hoping that they'll get as they walk out that virtual door?
This is probably not the answer that you were expecting, and it doesn't have too much to do with multiplication.
No
but
shame.
I think that, yes, I think that the thing that I want to leave teachers with is just either a light bulb moment about multiplication, because I truly believe that our light bulb moments fuel our teaching. When you are inspired, it changes how you show up in the classroom. And I hope teachers are left a little bit more curious about the other concepts they teach. Like, what else have I not thought about? Or what other concept in my teaching that maybe I am proceduralizing it a little bit, or maybe I need to dive deeper into. So I think that curiosity and that inspiration, like if I've done my job, if teachers leave my session feeling that way.
It's like a good Netflix ending, where you're just like, I can't wait to do the next episode, right? There's got to be more.
Right.
What I love is you call them light bulb moments. We always use the term epiphany moments, and it's like actually a really big part of, the work that Kyle and I are doing with districts across North America right now is how do you build more epiphany moments into your PD programming across a district for system-wide change. And, and the thing that I think, and that we get passionate about those epiphany moments, because you're right. Like a lot of times districts are saying like, let's make change, let's make pedagogical change. But when you focus on the pedagogical change, sometimes teachers might be like, I got to learn the math a little bit deeper, and then they go off and maybe have an epiphany moment. But if you focus on epiphany moments first for a teacher, guess what happens every single time a teacher has an epiphany moment? They say, how do I teach this better? Right? They always causes a change in a pedagogical change. So it's like, if you want pedagogical changes in your district or your school or with yourself, focus on the epiphany moment. Like, what other light bulb moment are we not having in mathematics that will inspire you to go and figure out how to teach that better? And now you don't have to worry about, are you making sure that we're changing our effective teaching practices? And
to recreate that epiphany moment for the students, right? Like, and I think that's the part, like it like gives you that fuel to go like, whoa, if I felt like I do now, like when you have an epiphany moment, a light bulb moment, you go, that was cool. And you're like, I want to do that with my kids, like, I don't want to just do what I had on the, on the slide or on the, the transparency that's stained yellow.
Brittany, absolutely.
We want to thank you for joining us here today and sharing your insights around your session coming up. We can't wait for your session in the summit. Folks, if you have not yet registered for the summit, get on over to makemathmoments.com/summit and get yourself registered. It's free. Get in there. You're going to hear Brittany's big takeaway among many others. So Brittany, thanks so much for joining us, and I can't wait. See you there.
Yeah. Thank you for having me.